Hello, my name is Kavyanjali of Class 12th. This is our art integrated project, and my groupmates were Kavya, Chitti, Pujita, Chaitanya, Akila, Divyasri, and Nirmala. So now let's begin. Our topic is crystal systems models. It is taken from the solid state chapter. So first of all, what is crystal systems? A crystal is a substance in which the particles are arranged in an orderly, repeating, three-dimensional pattern, and it is defined by its faces, which intersect with one another at specific angles, as well as they were classified into the general categories based on their shapes. So now let's discuss their classification in detailed manner.
Hi, I'm Kavyanjali of Class 12th. Today I'm here to explain about the crystal systems. First of all, crystal systems were classified into the 7 types. They were cubic, tetragonal, orthorhombic, hexagonal, rhombohedral or trigonal, monoclinic, triclinic. Now let us explain these 7 types of crystal systems in detailed manner. First is cubic. Cubic is the one where the length is equals to the breadth is equals to the height. It means A is equals to the B is also equals to the C, and the angles were alpha, beta, gamma. They were also equals to the 90 degrees. We can also see the possible variations in this cubic. They were primitive. Primitive means the corners of these cubes were occupied with the atoms. Example is this, where the corners of these cubes were occupied with the atoms. We can also see the possible variation of body centers, means one atom is inserted in the middle of this, and we can also see the possible variations of face centers, means face is occupied. The examples of this cubic system is sodium chloride, zinc, blends, copper. Next, the second type of system is the tetragonal. Tetragonal is the one where the length, breadth is equal but height is not equal, means A is equals to the B but B is not equals to the C. We can also see the angles of alpha, beta, gamma as the 90 degrees, and the possible variations in these tetragonals were primitive. Primitive means the edge of these tetragonals were occupied with the atoms. Examples of this primitive is this. Edge of the corners were occupied with the atoms. We can also see the second possible variations as body centered. Body centered means in the center of this were occupied with another one more atom. It is also called body centered possible variation of tetragonal. Next is the examples of these tetragonal systems where white tin oxides, terranium oxide, calcium sulfate. The third type of crystal system is the orthorhombic. Orthorhombic is the one where the length is not equals to the breadth is also not equals to the height, whereas angles of alpha, beta, gamma were equals to the 90 degrees. We can also see the possible variations in this orthorhombic is primitive. All the atoms were occupied at the corners of this orthorhombic. Next one is body centered, face centered and edge centered. The examples of this orthorhombic is rhombic, sulfur, potassium nitrate, barium sulfate. The fourth type of crystal system is the hexagonal. Hexagonal is the one where A is equals to the B but B is not equal to the C, and the angles of the alpha, beta were equals to the 90 degrees but gamma angle is equals to the 180 degrees. We can also see the possible variation in this hexagonal is the primitive. Primitive means corners of this hexagonal were occupied with the atoms. Next, the examples of this hexagonal system is the graphite, zinc oxide, Sirius. The next type of crystal system is the rhombohedral or trigonal. It exactly looks like the cube, but it tilted little bit and not equals to the 90 degrees angles way. But A is equals to the B is also equals to the C. And the examples of this rhombohedral or trigonals were calcite, calcium carbonate, lead sulfide, etc. The next type of crystal system is the monoclinic. Monoclinic is the one where the length is equals to the breadth. but breadth is not equals to the height. It means A is equals to the B, but B is not equals to the C. And the angles were alpha, beta were equals to the 90 degrees, but gamma were not equals to the 90 degrees. The possible variations in this monoclinic were primitive. Primitive means at the edge of the corners were occupied with the atoms. The next type of possible variations is the end-centered. The last type of crystal system is the triclinic. Triclinic is the one where the length is not equals to the breadth. Breadth is also not equals to the height. It means A is not equals to the B. B were also not equals to the C. And the angles were alpha, beta, gamma were also not equals to the 90 degrees. We can also see the possible variations in the triclinic is primitive. Mean edge of these corners were occupied with the atoms. The examples of these primitives were potassium dichromate, copper sulfate, boric acid. Based on all these type of crystal systems, we can also calculate the Bavarian lattices. Bavarian lattices of cubic is 3, means primitive, body-centered, face-centered were equals to the 3, and the orthorhombic of Bavarian lattices is equals to the 4, hexagonal is equals to 1, rhombohedral is equals to the 1, triclinic is equals to the 1, tetragonal is equals to the 2, monoclinic is equals to the 2. If you sum up all these, they were equal to the 14, and according to the Bavarian, there were only 14 types of crystal systems. Thank you very much for giving this wonderful opportunity. Next video will be continued by my friend Kavya.
Hello everyone, I am V Kavya. Now I am going to give details about uses of crystal systems in our daily life. Let's see.
The development of modern lasers has opened many doors to both research and applications. The ability of laser to focus precisely is due to high-quality crystals that help give rise to the laser beam. A variety of techniques are used to manufacture pure crystals for use in lasers. Many gemstones are crystals, including quartz, alumine, and diamond. In nature, minerals may take a wide variety of shapes, all derived from the 7 basic crystal systems. Crystal system predictions have been used to study organic molecules. Some, like diamonds, rubies, are known for their rarity and beauty. These are precious stones which are used in jewelry.
Up to now, we have studied that crystal in each system have a specific number of imaginary axes which are indicated by the letters A, B and C. These axes can vary in length and intersect at specific angles which are designated by the Greek letters alpha, beta and gamma. So, I conclude that every mineral on earth belongs to only one crystal system. So, crystal form is a definitive property that can be used to identify an unknown mineral. I hope you may understand this activity very well. Thank you.